5-4 is on the central limit theorem. And the central limit theorem is different because until now, 5-1, 5-2, 5-3, you've done a single thing. That is, what's the probability that a single thing is bigger than or less than or in between? So what if you wanted that the average of a group is bigger than or less than or in between? So this section is very similar to 5-2. The only difference is instead of one thing to find the probability, right? The one thing to convert to a z-score and then to find the probability, you're now doing a group of things to convert to a z-score to find the probability. Okay, so the central limit theorem, here's an example of the difference from 5-2 to 5-4 here. Before now, we've done stuff like this. The time it takes to drive between Vermilion and Elk Point is normally distributed with a mean of 14 and a standard deviation of 2.2. So find the probability that one trip between the towns will take more than 15 minutes. So this is what we did in 5-2. We found the probability that a trip will be more than 15 minutes by converting it first into a z-score. So we take 15 minus the mean, divide by standard deviation, and get 1 divided by 2.2, 0.45. And since it's more than, do we look up 0.45 on the table? Nope. We look up negative 0.45. So on page A16, we're looking up negative 0.45. And we get we get 32.64%. Right? And that probability should make sense, right? For one trip to be more than average, right? 15 minutes instead of 14. For one trip to be more than average is going to be around 30%. That makes sense, okay? So here's the difference of today's lesson. Now I want to know that if I traveled to Elk Point 2 weeks, right? For 2 weeks I went to Elk Point, a total of 9 trips. What is the probability that the average of those 9 trips took me more than 15 minutes? Okay, so think about this. Should the probability be higher or less than 32%? Do you think it's more likely for the average of 9 trips to take me 15 minutes or one trip to take me 15 minutes? Well, let's find out, okay? So here's the new part. Your mean is still going to stay your mean, right? This means the mean of the average, okay? So the mean of these average 9 trips is staying the average. That's still 15. Not 15, 14, sorry. Right? My mean is 14. The standard deviation of these mean 9 trips, though, changes. It's not 2.2 anymore. It's this, 2.2, right? Because that's my standard deviation, divided by the square root of n. What's n in this case? Well, the number of trips. The number of trips is 9. So I do the square root of 9, which is 3. So what's 2.2 divided by 3? 0.73. So my standard deviation changes. My mean stays the mean, but my standard deviation, if I'm talking about the average of a group, is going to change. Then everything else is the same. How do I convert this into a z-score? Well, I'm still going to use that same formula. So I would take the 15 minus the mean divided by now my new standard deviation, right, 0.73, and I get what? 1 divided by 0.73. I now get a z-score of 1.37. Okay. Now I'm still doing more than 15 minutes. So am I looking up 1.37? Nope, I'm looking up negative 1.37 because it's a more than. So negative 1.37 is 0.0853, so 8.53%. Right? So that's what it should have been, is less likely for the average of 9 trips to be more than the actual average, right? That makes sense. One trip, yeah, it could happen, one trip. But if I'm talking about 2 weeks worth of travel, if my 2 weeks worth of traveling is more than the average of what it should be taking, then what's wrong, right? What's going on? That should not happen. It's it's unlikely, right? Not unusual, because that's less than 5%, but 8%, that's unlikely. Okay, so that's the new part. Mean stays the mean, but you have to make a new standard deviation. So let's do another example. Oh, and before we do another example, we need to stop and talk about something very important. How do you know to assume normal distribution? Okay, so in order to assume normal distribution, it either has to tell us it's normally distributed, or we have to have a sample size of 30 or more. So it either has to say, assume normal distribution, or it has to have a sample size of 30 or more. If it meets one of those criteria, then I can go ahead and calculate a z-score and probability. If it doesn't meet one of those criteria, you say, I cannot assume normal distribution, therefore I cannot calculate the probability. Okay, it has to say either assume normal distribution or your n has to be 30 or more. That's really important. Okay, so now let's do an example here. Okay. So yeah, this example should look like what we did in 5-2. I'm gonna close out of this a second because I'm not getting my scrolling bar. How come I'm not getting my scrolling bar? There we go. There. Okay. So it says records indicate that the packages shipped by a certain trucking company have a mean weight of 510. Right? So that's important information. And a standard deviation of 90. 100 packages are being shipped today. That's my N. What is the probability that their mean weight will be, right? So this is talking about not just one package will be more than 530 pounds. It's saying that the average of the 100 packages, if I took the average of all 100 packages, what then is the probability that it's more than 530 pounds? Okay, so the first thing we need to look at is this. My mean stays the mean, but my standard deviation now is 90 over the square root of 100. Right? Since I'm talking about an average of a group, my standard deviation changes. So 90 divided by 10, because the square root of 100 is 10, would be 90 tenths. Oh. There we go. Okay, so now, using this mean and standard deviation, calculate more than 530 pounds. So just like we did before, my z equals 530 minus the mean, divide by standard deviation, right? And now my standard deviation is 9, not 90. So 530 minus 510 divided by 9 gives me 2.22. Okay, so on my table in A16, am I looking up 2.22? Nope, this is more than, so I'm looking up negative 2.22 because I want area to the right. So negative 2.22 is 0.0132. Nope. Negative 0.0132. Okay, how about this one? Less than 500 pounds. So now that we've done all this, now it goes faster because less than 500 pounds, I take 500 minus the mean, again divided by the new standard deviation. Oops, 500 divided by minus 510 divided by 9, negative 1.11. And it's less than, so am I looking up negative 1.11? Yes, I am, because that's area to the left. I don't change anything. So negative 1.11 is 0.1335. Okay, between 495 and 515. Okay, so if you remember, this is a great review. To do area in between, I find the z-score for both of those. All right, find the z-score for both of those to look up. So 495 minus 510 divided by 9. And then let's just do the other one since I'm right there. Divided by 9. Okay. Now, do I subtract the z-scores? No, do not subtract the z-scores. You're going to find the percents for both to subtract. So look up negative 1.67, 0.0475. Look up 0.56. .7123 and subtract them. So 0.7123 minus, right? Always the bigger minus the smaller because you can't have a negative percent. And I get 0.6648. Okay. So as you can see, it's everything we were doing in 5-2 except for the standard deviation changes. Okay. So instead of a single package, one package, it's talking about the average, the mean weight of 100 packages. Let's try another example. A new muscle relaxant is available. Researchers from the firm developing the relaxant have done studies that indicate that the time lapse between administration of the drug and beginning effects of the drug is normally distributed with a mean of 38 and a standard deviation of 5. The drug is administered to one patient selected at random. What's the probability that the time it takes for that drug to go into effect is 35 minutes or less? Okay, so come test time, this is what the struggle is. How do you know when we are doing central limit theorem? Okay, since I'm talking about one patient, right, is 35 minutes or less, this is a 5-2 question. It's just one patient, so I don't change anything. I take this 35 and change it into a z-score. Okay, now where it gets different, and I'll solve that in a minute here, I just want to go over this, is down here on the second question. It says the drug administered to a random sample of 10 patients what is the probability that the average time for those 10 patients, right, is 35 minutes or less? That's how you know then it's central limit theorem and you need to change the standard deviation. Okay, so let's go back up and do this first example. So let's finish this. So 35 minus 38 divided by 5 is negative 0.6. Okay, do I look up negative 0.6? Yes, because it's 35 minutes or less. That means area to the left. So look up negative 0.6 and I get 0.2743. Okay, so now how does this change for the 10 patients, right? For the 10 patients, my mean stays the mean, but my standard deviation is going to change. Right? My standard deviation is now going to become 5 over the square root of 10. Right? My mean stays the mean, but my standard deviation changes to what my standard deviation was, 5 over the square root of n, and I'm sampling 10 patients. So 5 divided by the square root is 1.58. Okay, so I'm solving this just like I did up here, but now instead of 5, I use my new standard deviation. So what's that? 35 minus 38 divided by 1.58, negative 1.9. Okay. Do I look up negative 1.9? Yes, because it's still 35 minutes or less. So if I look up negative 1.9, point 0.0287. Okay, so I have a smaller probability, and it's actually unusual, it's less than 5%, right? I have a smaller probability that the average of these 10 patients will be 35 minutes or less than one patient would be 35 minutes or less. Okay, and that makes sense because average is 38. So for 10 patients to all be less than average should be an unlikely event to happen. Okay. So your homework for this section is on page, let's see, 5-4. So page 271, and you're doing 27 through 38. Yes. So it says find the indicated probability and interpret the results. So it gives you the mean, it gives you the standard deviation, which you'll have to calculate a new standard deviation. And then once you get to 33, 33 through 38, kind of to help you out here, 33 through 38, you're comparing both one unit to a group. Okay, so kind of like that last example we did would be those problems. You're doing one where you don't change the standard deviation to then finding the probability of the group, which then you would change the standard deviation.